want to do a quick run through on semicircular arcs. So I just want to do anything on the form of z minus z1 ends up being on z minus z2 ends up being a semicircle, which equals theta. Now I just want to do the different cases. Let's make that a little bit neater. Z minus z1 on z minus z2. So if theta was to equal to 0, regardless of where z1 and z2 are, so say that was z1 and that was z1 and that was z2, because this one has to be like the first one all the time, okay? Then if 0 equals theta, then it's going to be on the outside. If theta was to be equal to pi, then if you had the same situation, we'd say you had z2 there, z1 there, the angle will be on the inside, okay? So that's where it's equal to 180. I kind of think of that as a 180 flat angle. That's how I remember it. If theta was equal to an acute angle, let's just say pi on 4, then that means that wherever you've got this, you've got your z1 has to be the first one, z2 the second one, then what you do is you make it a big circular arc like that. It's not a very good one. And if you go like this and you go here like that, that would be your centre. So the angle here is 45 and the centre there, actually it won't work for 45, let's just make it pi on 3. So that's equal to 60, so the angle at the centre would be 120. And from that triangle, because if you get the midpoint, you can get this length here. And from this right angle triangle that you can form inside here, you are then always able, because that'll be 60, you'll have this length here, which is the midpoint of Z1 and Z2. And that's that there, we get that length there. We can actually find, from here you can find the centre. Usually when it's on its side like that, you don't usually ask to find the centre. But the centre will sit inside. So normally, what you normally see it like is like this, okay, and it will be a circular arc. There's the centre, here's that there is your like 60, so that's the centre of the circle, so that'll be 120. And it's quite easy to use trig to be able to find the y value of that and the x value of that point that is actually the centre. Now the thing is, if theta is obtuse, so you have Z1 and Z2, if theta is obtuse, then in order to get an obtuse angle, that angle inside there has to be the obtuse angle. Say it was 120, okay. Now, just to make it really clear, this is based around, if you look at the most basic one, which is the one that sits on the x-axis, and then they all just follow suit. So if you have this and this is Z1, Z2, sorry, and Z1, if they're not, then that means that would be a negative angle, and if it's a negative angle, the negative angle, you just flip it over, okay? So you know it's a negative angle because, like, say you have the Z2 first instead of the Z1, like the one that's on this side instead of the other one, then that'll actually be a negative angle because you'll have, I'll show you that one in a minute. I'll just finish this. So if these are your two angles, Z1 and Z2, okay, then basically arg of Z1 is that angle, arg of Z2, say, is that angle. I'll call that beta actually. This angle here is your theta. So this is moving so that that angle is always theta. So therefore it will sit on a circle. It's not necessarily a semicircle. If the theta was equal to pi on 2, it would be a semicircle because the angle on the diameter is a right angle. So what that means is beta equals alpha plus theta. So theta equals beta minus the alpha. Okay, and that's using the exterior angle of a triangle. That's how it's originally proved. So when you've got this situation, if that is Z1 and Z2, and you have your acute angle here, and that is sitting on top of there, the centre for this one will be in the middle there, and say, you know, that there is z minus, I've got z2 there, so I'm going to change those, z minus z1 argument of it, because that's what that angle there represents. This angle here is the argument of z minus z2, which is equal to beta. And if you subtract those two angles, you get theta. And that's why when you've got z minus z1 on z minus z2 equals theta, when you subtract the two angles, you're actually subtracting, like you're subtracting the exterior angle of a triangle, which is this one, which equals the sum of the opposite two interior angles. So therefore alpha take away beta will give you this angle. And to get the centre, this is always 2 theta down here. So if you want to get the actual centre, the y part's there, you can always find that length in the triangle right here in yellow. And because that's 2 theta, you're always able to find this little angle. And you can just use trig to find it, and you can also use that then to find also the radius. I just want to make real clear what you mean by arg z minus z1. So if you want arg z minus 3, for example, that means you go to the number 3, draw a circle. Now if I said that equals pi on 2, or say pi on 3, that means that that angle there is equal to pi on 3, which is 60. But if I went z minus 1 plus I, and I tell you it equals 45, that is the angle that if you went to z minus 1 minus I, which is 1 minus 1, you go 1 minus 1, which is there, that means you're running that angle, and that angle is at 45 degrees.